Okay, the first thing you do when you're solving problems that are involving projectiles is to break it down into x and y axes. And before you get started, you need to fill in what you know and what you don't know. You automatically know in the x direction that there's no effect from gravity, or the acceleration does not occur in the x range. Okay, in the y-axis, the acceleration is caused from gravity, negative 9.8 meters per second squared. This is the y-axis. What is the next thing we know? Well, we have the speed of the car as it runs off the side of the table. That is the velocity in the x-axis. It is not only just the initial 3 meters per second, it is also the final velocity in the x direction. There is no jet engine attached to the car. There's no rocket fuel to fly through the air. Now, usually if we have happy and we know we got 3 things, but this case, this is just a loop. It does not help us solve for t or d. So now we have to look in what else do we know. All right, let's go up to the y-axis. So we're hanging out over here. In the y-axis, the desk is 1.6 meters high. So that is the displacement that is going to occur from the toy car. And technically, it's negative. Okay, because you're going down from the origin. Now it asks, how far from the edge of the desk will the toy land? So it's actually looking for this information. It's looking for this right here, D. But this doesn't really help us because we need 3 things. And this is just a loop over here and over here. So what else do I know? It's dropping. This is an implied concept. It's dropping. So you have to know that. It drops. All right, there's an S there. All right. So if you know it drops, now you have 3 things on this side. Happy, and you know, got 3 things. 1, 2, 3. Yes. Now solve for time. Always, always, always solve for time first. No matter what it's asking you, always solve for time first. All right. So how do I solve for time? Well, I got to pick an equation that does not have final velocity. Skip that one, skip that one. This is the choice. I know it looks a little complicated, but don't get freaked out. You have displacement is equal to v initial t plus 1/2 a t squared. This is a defect right there, so I'll have to reset. V initial t, and these are all in the y-axis. Okay, now I know this is 0 because it's just like dropping. Even though it's flying through the air as a toy car flings to the right, the initial velocity in the downwards y direction, this direction, is going to be 0. Now I rearrange my equation and I solve for t. T ends up being the square root of d times 2, or the height of the table, times 2, divided by gravity. Plug in your numbers, and you get 2 times negative 1.6 meters divided by negative 9.8 meters per second squared. Don't forget this is a parenthesis, so that's actually multiplication. And if you look at my units were meters divided by meter per second squared, which is the same thing as saying meters divided by, flip the fraction, cherubang it, second squared divided by meters. Now my meters cancel out. My only unit is second squared. So inside this square root symbol, I'll have a second squared. Final answer, if you plug it into your calculator correctly, you get time is equal to 5.7 meters. Now, time is universal. I plug it in here. Wow, not meters, seconds. Hopefully you caught my error. I can't speak correctly. 0.57 seconds. So now I'm going to put in 0.57 seconds. The double negatives cancel out to be positive, and now I put in 0.57 seconds. Now, depending on how accurate you keep everything, your numbers might be a little different. All right, I'm going to have to erase this to give me more room. I now have 3 things. 1, 2, 3, technically 4 things. But I can now solve for the range, or the how far away from the edge of the table the car fell. So I'm erasing this. Trying to clean this up a little bit so you can see it. Yay, this is the trick. Always use that time. Once you found time, everything is kind of easy. All right, so now I'm looking for the range. That's dx is equal to v initial in the x direction times time, plus, technically the equation says 1/2 at squared. Notice, again, I did not choose this one because it has velocity final in it. I didn't choose this one because it had velocity final. And I'm like, well, I actually do know it, if you look over here, but this equation works best. Why? Because a to the x is 0. No effect from gravity. In x-axis. Alright, continuing how to solve. If d equals vt, if d of x, the range, is equal to the initial velocity, x, times time, you just plug in what you know, 2.3 meters per second, times my time, 0.57 seconds. Seconds cancel out. No, seconds don't cancel out. But yeah, they do cancel out. I'm looking for meters anyways. There we go. Multiply those two numbers together. My distance range, or my distance from the table, is 1.31 meters. Voila. All right, that solves for 1A.